Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 6-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to understand the inverses of exponential and logarithmic functions. So remember, when we're dealing with an inverse, we have to do two things. The first thing that we have to do is to swap x and y. Once we do that, then we solve for y. And so when we go to find these inverses, that's my process, okay? So on part A, now remember, if ever you have like f of x or g of x, that's just the letter y. So when I rewrite this, I'm going to put x equals 10 to the y plus 1. So now my y is currently trapped inside of this exponent. Okay, it's just making that look more like a plus sign. So in order to take that y out of the exponent, I need to take the logarithm of both sides. Now remember, whenever you take a logarithm, you need to consider what the base of the exponent is that I'm trying to get rid of. So because this is trapped in a base 10, I'm going to take a logarithm base 10, or a common log of each side of this equation. All right, so on the left-hand side, I have the log of x, and on the right-hand side, the log and the 10, they cancel each other out, and I'm left with a y plus 1. So then now to get y alone, I'm going to go ahead and subtract 1 from each side of the equation. So I get the log of x minus 1 is equal to y. Now remember, unless I put grouping symbols around it, this minus 1 is not a part of the logarithm. Okay? So now let's try it for part B. So my first step is to swap my x and y's. So I get that x is equal to the log base 7 of y plus 5. Now in order to get rid of a logarithm, remember I have to exponentiate. I'm going to write that word down here. And when we exponentiate, what we do is we take each side of the equation and set it as an exponent to the same base. In this case, I'm going to use the base 7 because that will get rid of this logarithm on the left, or on the right. All right, so when I do this, I have 7 to the x is equal to, the 7 and the log 7 cancel, leaving me with y plus 5. And then to get the y alone, I'm going to go ahead and subtract 5 from each side. So I have 7 to the x minus 5 is equal to y. All right, now for little a, I think this is the try it, right? I flip my x and y. Now to get the y by itself, I need to get rid of that 3. So I'm going to take the log of each side. And anytime you take a log, you need to consider the base. So the base of my exponent is a 3, so the base of my log is also a 3. So on the left-hand side, I have the log base 3 of x, and on the right-hand side, I have y plus 2. So then I need to isolate y, so I'm going to subtract 2 from each side. And this turns into log base 3 of x minus 2 is equal to y. All right, and now for little b, I'm going to change out my x and my y, so I'm finding that inverse. Now notice here, this one's a little different than big B because there's not grouping symbols around the x plus 2. That means that before I exponentiate, I need to get rid of the 2, all right, because to exponentiate, you need the log alone. All right, so I'm going to go ahead and add 2 to each side before I deal with the exponent. So I have x plus 2 is equal to log base 7 of y. And now that the logarithm's alone, now I'm going to raise it as an exponent to 7. So on the left-hand side, I have 7 to the x plus 2, and on the right-hand side, I'm left with y. So there we have it, guys. That is how to find some inverses of exponential and logarithmic functions. Until next time.